If you need to test 100 people for COVID-19, how many tests would you need to run? Seems pretty simple. 100 people means 100 tests. Well, actually, we could optimize that number, and we could optimize it quite a bit. If we use an algorithm to group and test these people together, we can optimize all the way up to 56 tests per 100 people. And that's to know precisely for each person who has COVID-19 and who doesn't. This algorithm works because most tests come out negative. As of June 1st, only 5.1% of tests come out positive. So we could use that to our advantage. To showcase this algorithm, I'm going to be doing a little demonstration. For this demonstration, I'm going to be using this UV dye. In this demonstration, the UV dye represents the virus. So we're starting with 2 vials filled with water. I have randomly placed the virus in one, none, or both of the vials. Now we're going to add a little bit of both vials to this vial. Then we're going to mix it. Now we're going to dip a Q-tip into the vial, and then we're going to spread it on this piece of cardboard. As you can see, it glows under UV light. Since it is glowing, one or both of the vials contain the virus. That means we have to test one of the vials. Now we're going to spread this onto a piece of cardboard. As you can see, it's not glowing under the UV light, meaning vial A doesn't contain the virus. Now we know using the process of elimination that vial B is infected while vial A is perfectly healthy. Now we're going to do another demonstration. We're going to repeat what we did before. We're going to take a sample of both vials. Now we're going to shake the vial. Now we're going to dip another Q-tip into the vial. Now we're going to spread it onto another piece of cardboard. As you can see, it's not glowing under UV light, meaning both A and B don't contain the virus. As you can see, that saved us a single test. This algorithm is more efficient because most of the time we'll only need that one single test. Now the demonstration's group size was only 2 vials. And this group size is effective from the positive test rates from 21.4 to 38.2. But for smaller positive test rates, it makes sense to mix more vials together. And to find those optimal group sizes, I created a Python script to simulate this algorithm in action. And after running the simulation, you could find the optimal group size depending on the positive test percentage. Then I was able to approximate the relationship between those values to get a formula. So as you can see, if labs implement this algorithm, they'll be able to test more people faster, save money, and test more people in general.